In 1950, Alan Turing introduced the Turing test. If a computer can talk to a human through text and the human can't tell they're chatting with a machine, then the computer can be considered intelligent. Turing predicted that by 2000, machines would be able to pass this test. We are not quite there yet. The term artificial intelligence, or AI, was first used in 1956 at a conference in Dartmouth. One of the major scientists at that conference, Marvin Minsky, defines AI as the science of designing machines capable of doing things that require intelligence when they are done by humans. These things include complex mental processes like learning from perception, organizing memory, and exercising critical thinking. AI has been broken into 3 evolving stages. In artificial neurointelligence, AI is designed to perform specialized tasks like detecting breast cancer, recognizing faces. We are interacting with that type of AI regularly, daily. In artificial general intelligence, AI can perform human-like tasks. It will mean that machines will understand the world around us. We are not quite there yet. In artificial superintelligence, AI becomes smarter than humans. It is pure science fiction at that time. Right now, we are experiencing an AI boom with lots of excitement and progress in the field. This recent excitement is largely due to the advancement in machine learning and deep learning, 2 areas of AI that focus on teaching computers to learn from data. With more data available than ever before, these technologies have dramatically improved how systems can learn and function. Generative AI uses deep learning to generate images, music, video, etc. It is a subset of machine learning, even a subset of deep learning. In deep learning, the learning is done by deep neural networks. The name comes from neurons like in our brain. Neural networks are composed of layers, where each layer extracts different features, simulating how the brain perceives and understands the world. Machine learning methodologies are broken down into 3 categories: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning uses labeled data to teach models. The model learns to recognize the content of future data based on those labels. It is like children learn. They are shown pictures and they identify cats, dogs, cars, etc. Supervised learning includes 2 techniques, classification and regression. Classification is about putting data into categories. For example, determining whether a picture shows a cat or a dog based on previous examples of each. Regression is used when the relationship between the data points is needed. For example, predicting house prices from their sizes and their location. Unsupervised learning uses data without any labels. The system tries to learn the patterns and structure from the data itself. It creates clusters where data are more similar to each other. It's like organizing a pile of papers into stacks of related documents. In reinforcement learning, an agent, like a robot or software, makes decisions. It learns from new situations by trial and error and gets feedback, rewards in case of success, and penalty in case of failure. You can think about teaching a dog to catch a stick and give the dog a candy when it succeeds. AI applications are diverse, spanning robotics, autonomous cars, computer vision, natural language processing, and voice recognition. AI is multidisciplinary, drawing from fields like computer science, statistics, philosophy, linguistics, and psychology, enriching its development and capability. AI technology can significantly enhance problem solving and product development. But on the other side, unlike any other technology, AI has generated discussions on risks and challenges to be addressed, biases included. Bias is a tendency to prefer one thing, person, or group over another in a way that's unfair. It can be conscious or unconscious and affect decisions and judgment. Recognizing and addressing biases is key for equity. Biases present risks and vulnerabilities to consider when designing, developing, deploying, using, or auditing AI applications. Equity-centered design serves as a framework to address these issues. The National Institute of Standards and Technology, NIST, in the US, identifies 3 primary categories of AI biases. Systematic biases happen when the rules and system of an institution, like a company or government, unintentionally favor certain groups and disadvantage others. This can show up as sexism or racism, where the bias is built into the processes, making it difficult for certain groups to get the same opportunities or treatment than others. Think about hiring or law enforcement. Human biases are like mental shortcuts we use to make decisions quickly, but they can sometimes lead to mistakes in how we think and perceive things. These biases happen unconsciously and are based on rules or patterns we have picked up. For example, in behavioral economics, we look at biases like the anchoring effect, where the first piece of information we hear influences our decision more than it should, or confirmation bias, where we pay more attention to information that support our existing beliefs. Statistical and computational biases happen when the data used to train AI systems doesn't fully or accurately reflect the real world. This means the AI may not work well for everyone or every situation because it was trained on limited or skewed data. For example, if an AI is trained mostly on images of light-skinned people, it may not recognize darker-skinned faces as well. These biases can also come from using too simple or too complex mathematical models, or focusing too much on outlier data, or not managing them well. Current mitigations are mostly addressing AI biases, focusing on statistical and computational factors, and human and systemic factors are currently overlooked.